Now we're going to look at what to do when we're adding and subtracting rational expressions and the denominators are different. So if the denominators are not the same, then we have to determine the least common denominator by finding the least common multiple of the denominators. So once we determine the LCD, we're going to write each term of the expression with the LCD. And to do that, we're going to multiply each expression, if necessary, by the unit fraction that builds the fraction's denominator up to the LCD. So we'll do a few examples to get the idea of this, all right? And then once the denominators are the same, we can add or subtract the resulting rational expressions by adding or subtracting the numerators and leaving the result over the LCD. And we're not going to expand the denominator because once you simplify the numerator, there may be additional factoring that can be done and maybe more cancels out in the end. At any rate, once it's fully simplified, we can leave it in factored form. Okay, so before we get going on the algebra of this, let's just take a look at an example with numbers. So for instance, if you had 1/6 plus 2/9, and we were going to add those two fractions together. Their denominators are not the same, right? So we can't just add these fractions without doing a little bit of work. All right, so what is the least common multiple? Okay, so you can do the prime factorization and things like that. I'm just thinking about the times table here. Okay, what is the first number that I get to that will divide both 6 and 9? I'm thinking 18, right? So in order to get the 1/6 with a denominator of 18, I have to multiply the 6 by 3, yes? Okay, and if I multiply the denominator by 3, I must also multiply the numerator by 3. Okay, and then over here with 2/9, to get a denominator of 18, I have to multiply that denominator by 2. What you do to the denominator, you must also do to the numerator, right? So each one of these fractions, the first fraction I'm multiplying by 3 over 3, the second fraction I'm multiplying by 2 over 2, but I'm ultimately multiplying each one of those terms by a factor of 1, right? So let's continue here. So I'm going to have 3 over 18 plus 4 over 18, which is equivalent to 7 over 18, right? And we're done there, right? We can't reduce that any further. All right, so just wanting to get our feet wet. Sometimes just doing something with numbers before we throw the variables into the mix is a good idea. And really what we're doing with the variable expressions, it's pretty much the same thing, same idea. Okay, so here the directions on all of these examples: add or subtract the rational expression to a single rational expression and then simplify if possible. And if applicable, state any domain restrictions. Okay, so if we cancel things out in the end, we have to watch it there. Okay, so in this example, I have x plus 3 over x minus 5 plus x minus 2 over x plus 4. When I look at those denominators of x minus 5 and x plus 4, they don't have any factors in common, right? They have some terms in common, but they don't have any factors in common. So the LCD in this case is just going to be the product of both of them. So x minus 5 times x plus 4, right? It's good to write that out somewhere on the page so you have that idea. Okay, so in order to get both of those denominators to have an LCD of x minus 5 times x plus 4, what do I need to do to each of these fractions? The x plus 3 over x minus 5 is missing the x plus 4, right? So I have to multiply the numerator and denominator of that fraction by x plus 4, right? So essentially I'm multiplying it by x plus 4 over x plus 4, which is just 1, right? And then the second fraction of x minus 2 over x plus 4, that's missing the x minus 5, right? So I have to multiply the numerator and denominator times x minus 5. I'm going to have x plus 3 times x plus 4 plus x minus 2 times x minus 5, right? That's my numerator, all over the LCD of x minus 5 times x plus 4. Okay, be really careful here. You cannot cancel out factors of x plus 4 here, or x minus 5. because you're adding upstairs, right? So you've got to do all that FOILing, leave the denominator alone, but simplify the numerator. All right, so x plus 3 times x plus 4, we're going to have x squared. What's the middle term going to be? I've got 4x plus 3x, which is 7x. Again, if you need to write it out, please do so. And 3 times 4 is 12. And then I've got x minus 2 times x minus 5, which is going to be x squared. The middle term, we have minus 5x minus 2x, which is minus 7x. Negative 2 times negative 5 is positive 10. Divided by x minus 5 times x plus 4. I'm going to combine like terms in the numerator, so I'm going to have 2x squared, 7x minus 7x, that just goes away, and then I'll have 12 plus 10, which is 22, all divided by x minus 5 times x plus 4. So the only other thing that I see to do, in the numerator we could factor a 2 out, right? So we'd have 2 times x squared plus 11, but it doesn't help us simplify this any further, right? There are no common factors in the numerator and denominator to cancel. Okay, so we're done right there, and we never canceled anything out, right? So the domain restrictions of the original expression and the domain restrictions of the final expression match, right? Let's try another example. Same directions, we're adding or subtracting. In this case, we're adding, and we're going to try to combine this to a single expression and simplify it, and also state any domain restrictions if that applies. Okay, so in this particular problem, we've got 2 over x squared minus 9 plus 1 over 3x plus 9. And the thing that I notice right off the bat is that not only are the denominators not the same, but they're also factorable. So let's take a look, get all the factors going here. That's the first thing you want to do. If the denominators are factorable, factor everything in sight. So we've got 2 over x squared minus 9 is x plus 3 times x minus 3. It's the difference of squares. And then in the second fraction, 3x plus 9 is equivalent to 3 times x plus 3, right, when we factor a 3 out. Okay, so now let's take a look at the LCD here. I have a 3, plain old 3, right, and as well as x plus 3 and x minus 3, right? X plus 3 is included in both of those denominators, but it's only included once, right? So we include it once in the LCD. Okay, so in the first fraction, we have x plus 3 times x minus 3 in the denominator. The only thing that's missing in terms of getting building up to the LCD is 3, right? So I'm going to multiply top and bottom by 3, right? And then in the second fraction, I have 3 times x plus 3 in the denominator, so it's missing the x minus 3, right? So that's what I'm going to multiply top and bottom here to get the same denominators. So now in doing that, since I have a common denominator, 3 times 2 is 6, right? Plus, what's my new denominator in the second fraction? X minus 3, right? And that's all over 3 times x plus 3 times x minus 3, right? Simplify the numerator. 6 minus 3 is 3. I have 3 plus x. I'm going to go ahead and write that as x plus 3. So it looks like the 1 in the in the denominator. All over 3 times x plus 3 times x minus 3. Okay, and I notice that x plus 3 cancels, right? So my final reduced fraction is 1 over 3 times x minus 3. Okay, and I want to make sure to say there that x cannot be negative 3, right? So because we canceled that factor of x plus 3, and if we let x be negative 3 there, negative 3 plus 3 is 0, right? So that has to be stated as a domain restriction. So anytime you cancel something out in a final simplification, make sure you note the domain restriction there.